Okay, so today we are learning how about dividing rational numbers. The essential question is, why do we learn how to multiply fractions before we divide fractions? Your vocab is multiplicative inverse and reciprocal. So today we're basically going to divide fractions. Now, the big thing I want to, it's going to be similar to something we've done before, just not completely. So first, what I want to know is if we have the fraction 1/4, we're going to multiply it by something and get a 1. Right now, I want you guys to talk who you're sitting with. What do we need to multiply 1/4 in order to get 1?
1.
What do we need to multiply?
4 over 1. Same 4 over 1. Yeah, because there'll be 4
Okay, so what are we going to multiply it by?
4 over 1.
Why 4 over 1? Because we'll make it 4 over 4, which is the same as 4 divided by 4, which equals 1, right?
Mm-hmm.
So we have 4 over 1 equals 4 over 4. What if I pick a different number and I put 1 out of 7? What are we going to multiply 1/7 by to get 1? Why 7 over 1? Because it'll be 7 over 7. Well, then let's see about this. What if we do a 2/3? What should I multiply 2/3 by? You guys agree with her?
Mm-hmm.
Why 3 over 2?
Because if you switch them, your multiplications to make your whole number.
Hey, what you guys just did right here, that is called multiplicative inverse. And what a multiplicative inverse is when two numbers have a product of 1. When we have a product of 1, that gives you the multiplicative inverse. Now, when we take it, what were we doing with each one of these?
Switching it.
We were taking the second one, or the fraction I gave you, and you were flipping them, right?
Mm-hmm.
That is called reciprocal. That is when you flip the fraction. Any questions on that? No issues? Can we move on? Because that's not what this lesson is about. Multiplicative inverse, if that was what this lesson was about, we don't need a whole class for it. What it's about is about dividing those fractions. So that means we're going to start with a problem such as 4/9 divided by 3/5. There is a process to solve, and I'm actually going to solve it in 2 different ways so you can see the short way we solve it, but the longer method is going to show you why it works. And it does have to do with this reciprocal. So you guys are going to shorten this. I know you will because you always do, but remember, I'm the picky math teacher. You're going to have to actually explain that to me. When you go to solve it, we are going to go ahead and keep their first fraction. That's a big thing in math. The first term in any problem tends to stay the same until we actually start solving. But we are going to change this to multiply by the reciprocal. We're just going to keep the first one, change to multiply, and flip the second one, or reciprocal the second one. Because that makes it nice and easy. This is something we've solved before. Can 4 over 9 simplify? Can 5 over 3? Can 4 over 3?
No.
Can 5 over 9?
No.
Okay, so now we're going to solve. What is 4 times 5?
20.
What is 9 times 3?
27.
There's your answer. So those are steps. Does anyone know why we do this stuff?
Because if if you hadn't changed 3/5 to 5/3, you would have been able to simplify 3 and 9.
Well, that's what we would have done, but that wouldn't have been correct. My question is, do you know why we have to reciprocal that? Why can't we just take 4 divided by 3 and 9 divided by 5? Because that's what? Because it's what? Why couldn't I just solve it just like this? That's what I'm asking. There's a reason we reciprocal this. And the reason is, I'm going to show you a completely different way of solving this problem. It even looks different when we set it up. It is called a complex fraction. We have 4/9 over 3/5. Can you tell why it's called a complex fraction? It's a fraction inside of a fraction. You have 3 different fraction bars there. The thing is, this fraction bar is not a fraction bar, it's a division bar. But let me explain why this works. You have one big fraction with 2 small fractions in it. We don't like that many fractions. You guys don't tend to like fractions anyway. Your whole goal on a complex fraction is we're going to get this denominator equal to 1. You guys just did this at the beginning of the note. How do we get 3/5 to equal 1? Huh? Talk with each other. How do we get 3/5 to equal 1? What do? Jackie?
Multiply by the reciprocal.
We are going to multiply by this reciprocal. Because 3 times 5 is 15, and 5 times 3 is 15, which equals 1. We've multiplied by the reciprocal to get a denominator of 1. Now the reason we actually multiply it over here is because when we do a complex fractions, rules with fractions are very simple. What you do to the denominator, you have to do to the numerator. So whatever we did right here has to be exactly the same in the numerator. So we're going to multiply by 5/3. And when we solve this, you guys had 20, 27 divided by 1. What is 20 27 divided by 1? Still 20 27. It is still the same. Now, I did show this in an earlier class, and their response, I actually started with this one, and they go, so why do we have to do that bottom? In all honesty, I never expect you guys to use this one again. You can. You're more than welcome to use a complex fraction to solve. If you like it that way, great. Most of us do it this way. The biggest problem is you cannot forget to reciprocal. Any questions? Yes, Ruben.
So the second fraction, are we gonna flip it always to the second fraction?
If you see division, then yes. Okay, what if we did the problem of, this one's gonna change up a little bit. Now I'll do that. How do you think we read this problem?
-1 divided by 5.
-1 what?
Over 9.
You forgot that. -1/9 divided by 5/12. Could you solve it out this way? Yes, no, maybe so. Is there a method for solving it when it's set up this way? Yes, no, I can't hear you. I'm gonna quit looking at you guys, make you guys actually speak up.
Yeah, you could put the 12
We just
over.
did it, right? Or you can also rewrite it as -1/9 divided by 5/12. Am I going to care? Not at all. Which one do you guys like more? The complex or the horizontal?
Horizontal.
Okay, we'll solve the horizontal. What happens to -1/9?
Nothing.
Nothing. We're gonna keep it. What happens to division?
Change it to multiplication.
Change it to multiplying, and what happens to 5/7?
Switch them.
What's the word for switching them?
5/7.
Or 5/12. I read that completely wrong. I'm sorry. We reciprocal it, so it is now 12 over 5. Now it's back to our multiplication. Can 1 over 9 simplify? No. Can 12 over 5 simplify?
No.
Can 1 over 5 simplify?
No.
Can 12 over 9 simplify? By what? Divide both by 3 then. We now have -1/3 times 4/5. Now what? Multiply. What's 1 times 4?
4.
What's 3 times 5?
15.
Is that our answer?
No.
Amelia said no. Why did Amelia say no? Why did she think it's not the answer? What does a negative times a positive make?
A negative and negative.
Amelia, you were correct. That's
You're
not our final
genius.
answer. Don't freak out on me. You guys ready for some practice?
Yeah.
Okay. Student page.
Why are you not erasing?
Because I am not erasable.
What?
The whole.
Didn't reach Amelia. I'm breaking.
I want you guys to solve those two. You guys can work together.
No problem. Look at reaction. Wait, what? I don't know. Okay, so you didn't do that. So you still have to stay.
You put 2 check marks. You can do that. I'll check everyone else. Put it back to the original. She didn't check it. You just might not want to come. Oh, one, right? And that's fine. There you go. Now, show me. What is 15 divided by 3?
Oh, it's fine.
What I would do is when you do that, let's go. Half now. Divide it by 3. Okay. Let me see if I can.
Oh.
With that one.
Oh, the negative.
I'll make sure it comes down. All right, you guys ready for something harder?
Oh, kind of.
Kind of? Can we make it just a little bit harder? Little bit. Oh, it's nothing that hard. You know how to do it. I promise you, you know how to do this. Yes, you do. You just gotta see what I'm talking about.
Okay.
Ready?
Oh.
Why is that one any different? Because it has whole numbers. What do we call those? It's a whole number with a fraction. What do we call those? Mixed numbers. Can we solve those?
Yeah.
Yes. What's the first thing we're gonna do?
4 times 3.
You have to make them improper first. So what is 3 times 4?
12. Plus
Plus
2.
14 over 3. Negative 14 over 3.
Good. Don't forget that negative. Now what?
3 times 9.
That's 27.
Okay.
Plus 1?
28.
28 over 9. What happened to our division?
Addition.
Not yet. It doesn't. When you change it to improper, you keep that division.
Oh.
Because what's going to happen is if you don't do that, you're going to put multiplication, and then what did not happen? If you decide to flip that to multiplication right here, what did you not do?
You didn't make a reciprocal?
Exactly. Even those of us who remember to do it will forget that from time to time because we're skipping a step. We're trying to combine 2 into 1, and we forget. I do not want you skipping this part. What's our next step then?
Divide?
Not divide. What do we do? What happens to negative 14 over 3? So we're going to keep negative 14 over 3. What happens to division?
Changes to multiplication.
Changes to multiplication. What happens to 28 over 9?
So
Reciprocal. 9 over 28. Can you solve it from here?
yeah.
Go ahead. Could you cross reduce on this?
Mhm.
Okay, it might make things easier for you.
I'm missing something. Where should it be? I just want to use this, because then it looks like negative 3 halves divided by negative 1.
Some of you, in my opinion, just made it harder than necessary. What could you do right here at this step? You could reduce. You could simplify. Now, is it a must?
No.
No, but
Yeah.
we can make them smaller rather than having to take 14 times 9 and 3 times
Isn't it
28.
Oh, one.
Okay?
The one thing. Wait.
What do you end up with? I don't care which way you did. You don't have to erase your work. If you went ahead and multiplied, great. But when you are finished, you have one of these two answers. I will accept either one of those answers.
No, I got these.
Positive or negative?
Negative.
Why?
Because negative times positive is negative.
Yeah.
Try that problem.
Plus the negative. Because the negative doesn't plus the negative.
Okay. That makes sense when it is written.
Negative energy.
This means to multiply between.
What am I doing wrong? Negative. No.
Yeah, it is. Negative times negative.
It's okay. She said negative.
I'm mad enough.
The only reason those parentheses are in there.
I never said you were wrong.
Don't do something like that.
Wait, how did it? Okay, now I'm confusion. 30 plus
How did
25,
I
right?
get that? Right? Am I doing it right?
So look. Take number 34 over 12. Mm-hmm. Yeah. And then how many times in 30? And 12 go into 34. Yeah. Plus 2. And then the
Ruben.
leftover is 10. Divided by 3 quarters.
What's the negative times negative?
Oh, okay. No.
That can simplify.
No. You can simplify that.
But then to right, but
What are going to both 10 and 12?
They're both
Uh-huh.
don't do it, Miss Lomire. What?
Stop.
Apologize for
that.
Yes, you sound crazy.
I didn't even know what I was doing. I just got yelled at.
17 over 6, right?
Okay, is that solution? Is that quotient going to be positive or negative? Why is it positive?
It's third. Oh my god, it's 17. I'm not wrong.
Because you end up taking a negative times a negative. All right, now I'm really gonna mess with you guys.
No.
Yes, I am. Whether you like me to or not, I'm going to.
What do you
You ready for this? Are you sure?
think?
I like this one.
No.
So do I.
Yeah, 2 things. Oh, God. This is naughty. Oh, this is naughty.
There we go.
No.
Yes.
Yes. This was me. What Brianna just did.
Why are you guys so freaked out by that?
Letters. I don't know my ABC.
I don't care. You want to see how easy this is?
No.
Yes, I did.
Okay, fine. I won't show you how easy it is. Someone
No,
show
show-
one y'all.
show us. Don't show her.
us.
Okay, this is
I
easy.
already said no.
This is nice and easy. 3, 2, 1. Ignore the letters right now.
Okay.
We're going to pretend that's a bunch of numbers. We're just not reading them right now.
CPA.
We're going to ignore them right now. It is dividing fractions. What is the first thing we do with dividing fractions?
We flip the.
You change to multiply by the reciprocal. Has that changed anything of what we do?
No.
No. Now what would you do?
Simplify.
Simplify. What can anything go, or can 5 over 3 simplify?
Yes.
Yes.
No.
Oh
Yes.
no. Nope.
No.
Can a 1 over 15 simplify?
No.
No. Can 5 over 15 simplify?
Yes.
By what?
5.
Can 1 ABC simplify with 3 AB? Yes, but you guys don't understand it in this form. We'll get to the next step. We now have 1 over 3AB times ABC over 3, right?
What happened to the 1?
You can have the one that you don't have to have the one in front of the ABC, but it works.
Lab.
Okay, now we would multiply, right?
Yes.
What is 1 times 1 ABC?
ABC.
It is still 1 ABC. Whether you have that 1 or not, I don't care. What is 3AB times 3?
980.
You know how we've been simplifying and simplifying and simplifying?
Yeah.
You see that?
Yeah.
Okay, ignore it for just a moment. You're just listening to what I say. What is 5 divided by 5?
1.
12 divided by 12?
1.
Negative 3 divided by negative 3?
1.
Negative 108 divided by negative 108?
1.
10 divided by 10?
1.
12 divided by 12?
1.
8 divided by 8?
1.
Those are now 1. What is 1 times 1?
1.
They basically canceled out. You see these B's? Is there 1 in the numerator and 1 in the denominator? They cancel out. Your final answer is now 1C over 9. Or just C over 9. Oh, check.
Isn't the problem where it says like B over B divided by,
When they both do 1.
Divided by what?
like 15,
Oh, well, you made that easy. You really did make that easy. Should I complicate it a little bit?
No, just
Okay. Right here, what would you do, guys? Huh? I'm getting kind of, what happens to B over B? It stays the same.
Mm-hmm.
What happens to division?
Simplification.
What happens to 15 thirds?
Mm-hmm.
Okay, now what?
Can.
We're gonna cancel out. Can anything on here cancel out? What? What can go into both 3 and 15?
3.
Now Zuli right here is saying B and B. Well, isn't that what we did on this one? The B was on top of the B. I'm going to cover up everything else. It was a fraction B over B, right? Is this a fraction B over B? Then that was 1 times 3 divided by 3 is 1. 15 divided by 3 is 5. What's 1 times 1/5?
1/5.
Boom.
Wow.
You guys want to try to stuff me again?
Yeah.
We can keep going. Let's try. You already looked at it like, nope, I'm done. Why did you do that? All you're gonna do, you're gonna solve just like we have been. Just keep the letters attached until the very end when you can see what stacks up on top of each other. Good. Just 4 minutes left. But okay. This is the last problem I'm having you guys do. When you guys finish this problem, I have already emailed you your homework assignment.
Oh, okay.
I feel like you're always
Tarea.
homework.
Siempre da la tarea.